So what is matter? This is a very important question because chemistry is really the study of matter and how it changes, how it reacts and interacts with other things. So we define matter as anything that has both mass and volume. In other words, it has to contain stuff, physical particles, has to have a mass, and it has to take up some space. If it does not have these things, it's energy. Now, examples of energy are things like light or heat, where you can sense them, you know they exist, but they don't take up any space, they don't have any mass. Now, there are several different common forms of matter, and you probably know these as the states or phases of matter. The first state that we're going to talk about is the solid. So if we look at the diagram on the right here, I'll start this video, we'll see that the particles in a solid are very, very close together. And they stay that way. No particles are really moving around, but they're also not staying still. So even though each particle stays in the same spot, they are still vibrating. So the particles never actually stop moving. But these particles are very, very close together, and they vibrate. So let's write that down. So in a solid, the particles are very close together, and they vibrate. The next state of matter that we're going to look at is the liquid. So again, we'll look at this video at the right, and let's watch what happens. So in a liquid, the particles are still very, very close together. So you see most of the particles in here, every once in a while one escapes, but they quickly go back together. But now, instead of staying in the same place, the particles are vibrating as well as moving around each other. So the particles are vibrating kind of in place, and then they are able to slide around. And this is what allows a liquid to flow. So in a liquid, the particles are still close together, but they also flow around each other. The last phase of matter that we're going to look at is the gas. If we look at the video on the right, we'll see that the particles in a gas, unlike in a solid and a liquid, are very far apart. They're moving very quickly, and they're able to move freely away from each other. So in a gas, the particles move as far apart as possible and can move in all directions. They're not limited to sticking together or just vibrating in place. They're free to move around as far apart as possible from each other. So let's watch one more video. This video shows water molecules. So right now they are in the solid phase. They're stuck together, only vibrating. But if I add heat, you see they start vibrating faster and faster until we hit the melting point, and now they can move around as a liquid. They're still close together, but they're able to flow around each other. As you can see, we're at 339 Kelvin, which is just above the freezing point or melting point. Now, as we add more heat, more energy, the particles can move even faster, escaping the forces that hold them together, and now they can move about the container freely as a gas. Notice that as I add more heat, the temperature goes up, and the particles move faster and faster. Now we can do the same thing in reverse. If I cool them down, I'm lowering the temperature, the particles are slowing down, And once we get to the boiling point around 373 Kelvin, the particles come back together as a liquid. Once we get down below 273, now the particles can only vibrate and they're stuck together as a solid. Now, what does this tell us? Well, it tells us there's a close relationship between the movement of particles and their temperature. So let's look at what that is. Temperature is actually defined as a measure of the average kinetic energy, which is equivalent to speed, of the particles of a substance. So the higher the temperature, the faster the particles move. The faster they move, the more types of motion they'll be able to have. So as you warm up a solid, the particles go from vibrating, they start moving faster and faster until they can move around each other. Eventually they move fast enough that they can escape the forces that hold them together and they can turn into a gas. As you cool those particles down, they come back together because they're no longer moving fast enough to escape the forces that want to hold them together.